Earlier, I had told you that there are two main models for describing how bonding occurs. We spent most of our time in this chapter talking about valence bond theory because that's going to be the most practical one for us to deduce the shape and the size of molecules and figure out where the hybrid orbitals are, and so on. The other theory, though, that I alluded to earlier is molecular orbital theory. And rather than just thinking about bonds, about hybrid orbitals overlapping, molecular orbital theory considers what happens to the electrons in the entire molecule. Rather than just dealing with one bond at a time, we're looking at how the whole molecule works. So to get some sigma bonding happening down in here, I've got two hydrogen atoms, for instance, with their own 1s orbitals, and those two hydrogen atoms can combine in two ways. Just like waves can combine productively, or they can combine destructively. They can reinforce each other. We can sort of think of it like spins. If they had the same spin, they would sort of reinforce each other, but that's not exactly what happens with the electrons. But we can just imagine these orbitals reinforce each other, or they can be canceling each other out. So when they're canceling each other out, there is a node where there's no electron density in between those atoms. So a bonding molecular orbital is one where there's electron density between the atoms. Right? That defines a bond for us. Anti-bonding is where there's no electron density. So the two electrons that we originally started with occupy a bonding molecular orbital, which means those electrons can participate in that sort of bonding. So pi bonding happens sort of in a similar way. The two p orbitals combine together to make a bonding molecular orbital, which looks a lot like that pi bond that we talked about before, with one big area above and one area below the sigma bond in there. So that's a bonding molecular orbital. An anti-bonding molecular orbital always has that node in between there. So there are no electrons that are occupying this anti-bonding molecular orbital when it is in its normal ground state. So that's about all we need to know about molecular orbital theory right now. Please don't bog yourself down in trying to figure out why that node is there and what's bonding and anti-bonding and so on. Just have a basic familiarity with understanding that bonding molecular orbitals have electron density between the atoms. That's why we call it bonding. In second semester, we'll delve quite a bit more into molecular orbital theory because it's very useful to us when we're describing systems of pi bonds. So if we have a molecule that has several pi bonds in it, alternating throughout the molecule, they can all sort of interact together, and that's where molecular orbital theory really becomes useful to us. So we won't really talk about it at all until then. So